हेलो स्टूडेंट्स, मोस्ट वेलकम इन मैथ रीथ अकेडमी। तो इंटीग्रल कैलकुलस की थर्ड लेक्चर में आप सभी का स्वागत है। सो डेफिनेट इंटीग्रल्स पढ़ेंगे आज। और डेफिनेट इंटीग्रल्स क्या होते हैं, उनकी प्रॉपर्टीज क्या होती हैं, टुडे वी विल डिस्कस। तो एज वी नो कि हमारे पास जो डेफिनेट इंटीग्रल होता है दैट इज डिफाइंड इन सम इंटरवल इन सम रीजन। ओके, सो वी हैव सपोज दैट वी हैव डेफिनेट इंटीग्रल a to b of fx dx. Okay, and the integration of this fx is capital Fx, small fx. Then if you are applying the limits from a to b, so we can have fb minus fa. सो ये इस तरीके से हमारे पास लिमिट्स अप्लाई होती हैं और इस तरीके से हम डेफिनेट इंटीग्रल कैलकुलेट करते हैं। वी नो अबाउट इट। ओके, and if the derivative of this capital Fx is small fx, then you can easily say that the integration of small fx will be capital Fx. Okay, now some properties we have to learn. So properties of definite integral. First property is that कि whatever the variable we choose, if we are integrating from a to b fx dx, okay, so if you are just replacing this x with y, suppose that this is fy and this is dy, so whatever variable we choose, x रख दें, t रख दें, कुछ भी, अगर हम इसको suppose that t रख देते हैं and with this one, so so it is clear that the variable is dummy here, because in each case अगर हम इसमें कैलकुलेट करने जाएंगे तो एफ एक्स का डेरिवेटिव कैपिटल एफ टी हो जाए, एफ एक्स हो जाएगा। and then you can, when you apply this limit, you will get this is fb minus fa। एंड सिमिलरली यहाँ पर भी हमारे पास सेम आए, क्योंकि यहाँ पर हमारे पास जो वैल्यूज आ रही हैं दैट इज some numerical value, and then numerical value will be same for each. And here also we can have ft and then apply the derivative, a limit, this will be becomes this is fv minus minus fa. So in each case you can see these both are all the equal, so whatever the variable we can choose, in each case the value of the integral remains the same। तो अगर हमारे पास सपोज दैट कहीं पर हमारे पास ऐसे लिखा हुआ है ए टू बी एफ एक्स डी एक्स, सो यू कैन इजिली कन्वर्ट एनी ऑफ द वेरिएबल। तो जो भी सुटेबल है, अगर कहीं पर कोई कैलकुलेशन कर रहे हो और हमें वहां पर जरूरत है, तो हम अपने रिक्वायरमेंट के अकॉर्डिंग हम उसको उस वेरिएबल में कन्वर्ट कर देंगे। तो दिस इज योर एफ टी डी टी एज वेल, this both are equal। Okay, so this is first property, just remember it। Okay, in the definite integral। Okay, what is the second property of the definite integral? So here what is second one? So this is first one, and first one is what, we can able to change any of the variable। Okay, second है if you changing the order of the limits, है ना। we know that if we are something written here a and b affects, this is definite integral, so this is called upper limit and this is called lower limit। Okay, so if you are interchange this upper and lower limit, the value becomes with the negative sign। Okay, so if you have the integral from fx dx, okay, the value of this integration is capital Fx. So it will gives definitely this is integration from a to b fx dx is just equal to negative times b to a। fx dx. So it is very easy, you can easily show it. अगर हम यहाँ पर LHS लेके चलते हैं और we want to RHS, so you can easily have capital fx. Wait a second. तो यहाँ पर हम इंटीग्रेशन करेंगे, दिस इज a to b fx dx and you are applying okay, so you get this capital Fx and this limit applied from a to b, and from here you can have fb minus fa. So here this b is the upper limit and a is the lower limit. If you take negative outside, then you have fa minus of fb. Now you can easily write this like fx. This is from from a to b. And now you can easily say this is integration from b to a or fx dx. Okay. So if you are interchanging the upper and lower limit, you will get the negative of the previous integral. Okay. So, this implies you can easily see the integration of a to b of fx dx is just equal to negative times of the b to a of fx dx. Okay, so this is the second property of the integral and definite integral basically. Okay, so you just remember these things. So first, if we can change any of the variable, we can put any of the variable in the definite integral. It doesn't matter, you will get the same result. And another thing, if you are interchanging the upper and lower limit, you will get a negative sign. Okay, so uh, third one. Third one is property what? I'm changing the pen. So third property is this integration from a to b fx dx. Just a second. One call is. Sorry, ये कॉल आ गया था. तो from a to b fx dx. Okay. So if you break this interval, if suppose that we have an interval from a to b. Okay, so we know that function should be continuous for the integration. Okay, function should be it is continuous throughout the interval. If we break this interval with this c, okay, so now we have two intervals. This is a to b, a to c, and c to b. So integration will be possible in the both the interval from a to c and c to b, because the function is continuous throughout the interval a comma b, so it will be possible. But you can easily calculate this interval a to c and c to b, and you add up, you will get the integration from a to b. Whole integration will sum up the things. Okay, so this integration is possible here. So this is you can easily see, if there is some point between the interval a comma b, we can able to break this interval and break this integration as well. Okay, so this is from a to c, obviously a to c fx dx, and plus this is integration c to b fx dx. So this is very simple. You can easily see in LHS the value will be fb minus fa. What will be the RHS? Let us see. So if you are calculating, this is from a to c fx dx, and this is from c to b fx dx, and this will be equals to capital fx, and you are applying the limit from a to c, and plus this is capital fx, this is from a c to b. Now you just put it here, this is fc minus of fa, upper limit minus lower limit, plus this is fb minus of fc. You can cancel it out and you will get from here, this is fb minus of fa, and this is same as LHS. So this implies you can this is one interval. You can break in finite number of intervals. Okay, so if you want to break it in the finite number of intervals, here this C is between A and B. If you are have some finite number of intervals, you can break it. Okay, so generalization of this result is what? So in general, so if you are having suppose that it is A is between some point C1, which is C2, C3, and so on, and we break it in some point. Suppose that we break it in some point Cn, and this is lesser than B. Okay, so if you are going to break this interval from A to B of fx dx, so you can able to break because so you can just from A to C1 of fx dx plus this is C1 to C2 of fx dx, and this is plus and so on. This is integration from Cn minus 1 up to Cn of fx dx, and plus this is Cn to B of fx dx. So you can break the interval as you want. Okay, in a finite number of intervals. So this is the very helpful, because in some time it is difficult to integrate a function throughout the interval, but if you are breaking that interval, you can able to calculate and then sum up um, all the integrals, and you will get the integration of the whole interval. Okay, so this is the third result of the definite integral. Okay, so in a different integral, it is possible you can break break the interval and you can integrate. Okay, next, fourth number, and these properties very important property, so you should remember, you remember all these properties. So next is what? The integration from, if you are have integrating from, you integrating from 0 to a, this is from 0 to a of fx dx, you are integrating from 0 to a, so you can integrate it from a 0 to a f of a minus x dx. Even though not given in your textbook, even though you, if you have some a to b uh, fx dx is just equal to a to b f of a plus b minus x dx. This is a more generalization of this result. Okay, so let us prove this first one, that you can replace this x. Here what we replaced, we replaced this x with a minus x, and you will get the same result. You will get the same result. So let's write the proof of it. So we will do it by the substitution method. It is very simple. So we are going to show that this integral RHS is just equal to LHS. So I'm just taking RHS here. So this is, I'm taking integration 0 to a of f of a minus x of dx. Okay, so I'm just taking here using the substitution method. We integrate by the substitution method. Let a minus x is just equal to t. So when you are integrating, you will get this dx minus of dx is equals to dt, and this implies this dx is just equal to minus dt. And the place of a minus x is, just put t here. Okay, and you can see, according to this substitution, the limit also changes. Okay, So you put here x is equals to 0, this t will be equal to a. When x is to, when this is x is equals to 0, then t is equals to a. And when this x is equals to a, this t becomes 0. Okay, so when you are substituting this, when you substituting in this interval from 0 to a of f of a minus x of dx, this substitution you will can say when x is equals to 0, then t becomes a, this limit from a to 0, and this is ft, and in the place of dx you can put minus times of dt. So from here you can negative times from a to 0, this is your ft dt. Okay, and one thing we know, when you are interchanging the limits, you become the negative of that interval. So negative here है पहले से, this is negative times a 0 to a or ft dt by the second property. This is second property अभी हमने पढ़ा था, उस प्रॉपर्टी की मदद से you can easily say this thing will have minus minus plus. This is from 0 to a. This is your ft dt. Now, क्योंकि हमें पता है कि whatever here x और t और y from the first variable कुछ भी हो सकता है, ठीक है, but value will be the same. तो this value is just equal to as of the LHS. Okay, so यहाँ पर आप क्या कर सकते हैं, दिस यू कैन जस्ट राइट लाइक दिस इज एफ एक्स ऑफ डी एक्स इज जस्ट इक्वल टू एल एच एस. ओके, बाई वन, बाई प्रॉपर्टी फर्स्ट प्रॉपर्टी की मदद से वी कैन से, बिकॉज इट डजंट मैटर कि व्हाट एवर द वेरिएबल इज. ओके, सो तो दिस implies you can easily say integration from 0 to a, integration from 0 to a, 0 to a of fx dx is just equal to this is 0 to a of f of a minus x times dx. तो you just remember इसका जो मोन जनरलाइज पार्ट है उसको भी जरा देख लेते हैं. And you can say integration of a to b f of a plus b minus x of dx. You can just say x of dx is just equal to integration from a to b f of a plus b minus, ध्यान दीजिए हमने दोनों लिमिट्स को ऐड करा है एंड देन हमने x को सब्ट्रैक्ट करा है. सो इन दिस RHS we can substitute, है ना. तो this is your a to b and this will be what, this is f of a plus b minus x d. सिमिलरली हम इसको भी कर सकते हैं, तो इसमें भी हम क्या करेंगे, लेट a plus b minus x is equals to t. This implies minus of dx is equals to dt. Minus of dx is equals to dt, and this from here you can get dx is just equal to negative times dt. अब यहां पर ध्यान दीजिएगा, अब हम लिमिट्स रखेंगे x की. व्हेन x इज इक्वल्स टू a, जब x बराबर a पुट करेंगे तो a माइनस a इक्वल्स टू 0, a और a कैंसिल हो जाएगा, b बचेगा, इसमें t इज इक्वल्स टू b. एंड व्हेन दिस x इज इक्वल्स टू b, देन t बिकम्स a. ओके, सो अब इसकी जो लिमिट्स हैं वो चेंज हो जाएंगी, ये जब सब्स्टिट्यूशन करेंगे तो दिस इंप्लाइज this becomes a to b, b to a. Now when x equals to a, then t is b. So you get b to a f of t, and this is minus times of dt. And from here you will get negative times b to a of ft dt. अब फिर से इसको फर्दर आप चेंज कर दीजिए. तो फर्दर अगर हम इसको चेंज करेंगे बाय द फर्स्ट प्रॉपर्टी, you can by the second property you can have this is a to b of ft dt, and then you can write like this to be fx dx. Okay, and that is equals to LHS. So whatever the limits, if you add up and subtract x and replace this x with this a plus b minus x, the value of the integral remain the same. So this is a very important result. This is your that was what, a to b fx dx is just equal to integration from a to b f of a plus b minus x of dx. So this is about the property 4. Now the property 5 is depending on the function is odd or even. Okay, that will be depending on the function that is even or odd. So the fifth number property is what? So integration 0 to a fx is equals to fx dx have given two values. It will be 0 or it 2 times 0 to a of fx dx. Okay, if fx is an odd function, if fx is, it will be 0, 0 if fx is an odd function, or it will be this type 2 times of 0 to a of fx dx. I think this is negative one thing. Yeah. This is minus times of a. Okay, so if minus a to a fx dx is equals to, it will be 0 if fx is odd, and this is 0 to a is 0 to a up 2 times of 0 to a f dx is if fx is an even function. Okay, so let us prove this thing. So for let fx is an okay, so let fx is an odd function. Odd function. Okay, so I'm going to prove this thing. Okay, so I'm just taking this is from minus a to a of fx dx. Okay, so what we are going to do here, we just replacing, because we know that odd means f of minus x is just equal to minus times of fx. This is meaning of the odd. Okay, so if you are replacing this let this is x is replacing with negative times t, so this implies dx will be equal to minus times of dt. So from here you can and when you can just put x is equals to minus a, this implies this t will be equal to a, and when x is equals to a, then t will be equal to minus times a. So you can just replacing this, you can have, now it will becomes when x barabar minus a, then t will be plus of a. So there will be a to minus of a, and this is f of minus times of t. This is minus times of t. Okay, and this is minus times of t, and it will be minus of dt, minus times of dt. Okay, So you know that we took a function which is odd. So you can have minus times of ft and minus of minus dt is here. So it will be minus minus of plus. It means this is a2 minus a, and this is your ft dt. And in the in the place of t, you can put x here. So simply you can just write this is a2 minus a. This is fx into dx. So from this expression you will get, आपको क्या मिला? This implies this is from a2 minus a to a of fx dx is just equal to a2 minus a of fx dx. In the place of, you can, if you are interchanging in the RHS of the limits, so you will have negative times minus a to a of fx dx. And now you just add up in the right hand side. You can just move it. This is on the right hand side. So it will be 2 times. It will be 2 times. It will be 2 times minus a to a of fx dx is just equal to 0. So from here you will get minus a to a of fx dx is just equal to 0. When this is f of minus x is just equal to minus fx. It means odd function. Okay, so if function is odd, you can easily say the integration, the definite integration from minus a to a of fx dx is equals to 0. If you are going to see some examples, so you can also see, because you know that sine is an odd function. So sine x, integration from minus pi to pi of dx is just equal to 0. If you want how it is equal to 0, तो यू कैन इंटीग्रेट इट. साइन एक्स का इंटीग्रेशन क्या होता है तुम्हारे पास? यू कैन हैव minus of cos x, and this is minus pi to pi, and if you are putting this is minus of cos pi, and this is plus of cos of minus pi, and here you can have minus of minus 1, and it is also equal to minus 1, so you will get 0. So this is same value will be given 0. And one thing also we know that if whatever the value is here, it doesn't matter. You know that cos of minus theta is just equal to cos theta. Okay, so if you have some angle, suppose that we have some angle minus theta to theta, or you want to know the value of it, so definitely this value will be equal to 0. It's no doubt, because we have proved it. But if you want to calculate in this way, the cos theta, cos x, because integration of this will be minus of cos x minus theta to theta, and you applying this is minus of cos theta, and this is plus of cos minus theta, and then you have minus cos theta, and you know that cos of minus theta is again cos theta, so it will be again cos theta, and then you cancel it out, so you will get 0 again. So this is basically the odd function. If the function is odd and you are integrating from the negative to some positive number, same positive number, then the integral will become 0. This is a very powerful technique. If you know the function is your odd, then you easily say. Okay, next, if function is even, then how we can prove the value? So if fx is an even function, if it is a even function, so what meaning of even function? It means f of negative of x is just equal to fx. This is the odd function. Okay, so we have to prove this is minus of a to a of fx dx is just equal to 2 times integration from 0 to a of fx dx for this even function. Okay, so let's starting with this. This is from this fx dx. Okay, so हमें क्या करना है? अब हम इसको क्या करेंगे, ब्रेक करेंगे, बिकॉज वी आर मूविंग फ्रॉम some negative number to positive number. So definitely there is somewhere 0. So we can break this interval in this minus a to 0 and 0 to a. So it will be equals to minus a to 0 of fx dx. इसको हमने देखा था कि we can break the interval and this value will be remain the same, and this is 0 to a of fx dx. So there is no need to do with this expression. We have to do something here. What we do, but simply we replace x with minus times t. So d will be equals to minus of dt, and when x is equals to minus of a, then this t becomes a, and this when x is equals to 0, then t becomes equals to 0. So if you are doing with this first term, you will get this is from a to 0, okay, and this is f of minus of t, and this with this dx is equals to minus of dt, and with this term we are no need to do anything. Okay, we know that function is even, then f of minus t will equal to ft. So you can have this is ft and minus will be outside. This is from a to 0 ft dt, and plus this is 0 to a, this is fx dx. So one thing, we can change this variable as we want x here. So this is fx dx, you can write here 0 to a, and when you interchanging these limits, you will becomes this is a 0 to a of fx dx, and this is plus from 0 to a of fx dx. This is 2 times, this is from 0 to a of fx dx. Okay, so this implies if function is even, so this integration from minus a to a of fx dx will becomes equals to 2 times 0 to a of fx dx. Okay, this is when fx is even. So if we know the function is even or odd, according to that we can shift or change our definite integral. Okay, so this thing, the fifth number, uh, so this is some periodic function according to this property, some periodic function property. So if the period is 2a, so this is a sixth number property, and if you have this is 0 to 2a, and this is your fx dx, so this will be equal to 2 times 0 to a fx dx if f of 2a minus x is just equal to fx, first is this, and it will be equal to 0 if this is f of 2a minus x is just equal to minus of fx. So this is also very true, very easy. So let us prove it. So this is 0 to 2a fx dx. So we can easily break this interval. Okay, how we can break it? Uh, we can break like this. I'm not going to break. I'm just using this property. This is 0 to a, and f of a minus x dx is just equal to 0 to a fx dx. Okay, so we can apply this limit. So from here you can just have 0 to 2a, and this is f of 2a minus x, because in the place of a this is 2a. And now if you are choosing this one, so you can 0 to 2a, and in this place you can negative times of fx of dx. Okay, taking this is f of 2a minus x is just equal to negative times fx. So from here you will get this is minus times integration 0 to 2a, this is your fx dx. Okay, and if you are just transferring in the right hand side, so it will be becomes plus. So this is 0 to 2a fx dx, plus this is 0 to 2a, this is fx dx, is just equal to 2 times 0 to 2a fx dx is just equal to 0. And from here you will get integration 0 to 2a of fx dx is just equal to 0. So if here is that some period is written, मतलब some their fx is some periodic function, and 2a is period, it is principal or some general period, then you can easily say this is not it's negative times of fx. Okay, so if it is negative times of fx, then it becomes equal to 0, then it will be give some 0 value. Okay, so 2a minus 2a minus x is equals to negative times of fx. Okay, so now let's prove that this is from 0 to 2 pi 2a fx dx is just equal to 2 times 0 to a of fx dx, when if this is f of 2a minus x is just equal to fx. Okay, this is periodic function period 2a. Okay, so let us prove this. So if it is equals to minus x, then it becomes 0. If it is equals to x, then it will be up 2 times 0 to a. So let us see how. So this is so so it is 0 to 2a. Okay, okay, and this is your fx of dx. So we can break this interval from 0 to a fx dx, and this is from integration from a to 2a, and this is your fx dx. So there is no need to do with this first term. I'm just taking this second term. Okay, so this is I'm taking second term here. This is first and this is second term. So this is from a to 2a. This is f of x of dx. So now you can this replace x. Okay, this replace with the uh, with you can just have you just put this x is equals to 2a plus t. So put x is equals to 2a minus t. Okay, so when ध्यान दीजिएगा, when here you can just have t is equals to what, 2a minus x is easily. So when x is equals to a, then t is equals to 2a minus a, and that will be equals to a. And when x is equals to 2a, then t is equals to 0. 2a minus 2a is 0. So and when you are taking derivative here, you will have dx is equals to negative times of dt, because 2a is a constant, so it will be negative times of dt. So from here you can easily see when x is equals to a, then t is equals to a. So it will be a, and here it will be 0. In the place of x, you can put here this is 2a minus t, and in the place of dx, this is minus dt. So from here it is equals to minus integration from a to 0, and this will be f of 2a minus t of dt. And in this place you can just put ft, because you know that f of 2a minus t, 2a minus x is equals to fx. Okay, so you can just put it in minus negative a to 0, and this is f of t of dt is just equal to if you are interchanging the limit, you can just have f from 0 to a of ft dt. Okay, and you're replacing with the t with the x. So this is 0 to a of fx dx. So this is nothing. This is simply equal to this same as. So you can easily see this is 0 to a of fx dx, if plus this is 0 to a of fx dx is just equal to 2 times of this interval 0 to a of fx dx. When this f of 2a minus x is just equal to fx. Okay. So these are some properties, basic properties of definite integral in the 12th standard. I think आप सभी लोगों ने पढ़ा होगा, और ये याद होना चाहिए। तो एक बार हम फिर से इनको रिकॉल कर लेते हैं, और इनको हमें याद रखना है। ठीक है। तो पहली प्रॉपर्टी हमने ये पढ़ा कि इंटीग्रेशन definite integral from a to b of fx dx will be same as if whatever the variable, it doesn't matter. So this is ft dt. Okay, these are both are same. Second हमने पढ़ा if you are interchanging the limits, the negative sign appear. So this is from b to a of fx dx. We have proved this thing. थर्ड हमने पढ़ा कि वी कैन ब्रेक इट, है ना, वी कैन ब्रेक द इंटरवल in sub intervals, and you can able to calculate such a large interval in the pieces. So this is from a to b of fx dx is just equal to this is from a to some interval c, some point c dx, and plus this is fc to b of fx dx. Okay. And number 4, we saw seen that it from 0 to a fx dx is just equal to 0 to a f of a minus x of dx. They both will be the same. What was the fifth? Fifth is what? The integration from the negative a to positive a of fx dx is just equal to 0 if fx is odd, and 2 times 0 to a of fx if fx is even. And in the last sixth, we have just studied that if integration of 0 to 2a fx dx is just equal to 2 times of 0 to a fx dx, if this is f of 2a minus x is just equal to fx, and it will be 0 if f of 2a minus x is just equal to negative times of fx. Okay, so these formulas we have studied for these are called properties of definite integral. So we remember these properties, and if there is somewhere it needed, we will use it. Okay, so let's do one problem here. एक सवाल कर लेते हैं, कोई भी एक क्वेश्चन कर लेते हैं। एक सवाल है 2007 एलयू में पूछा जाए, आपकी एक्सरसाइज से कर देते हैं प्रॉब्लम में। सो एक्सरसाइज में फर्स्ट नंबर ही प्रॉब्लम है, क्वेश्चन नंबर 1, और ये LU में 2007 में पूछी गई प्रॉब्लम. ओके. So integration we have to calculate zero integration from 0 to pi by 2 root of sin x divided by root of sin x plus root of cos x of dx. इसका हमें सोल्यूशन निकालना है. तो बेसिकली हमें इस इंटीग्रल को कैलकुलेट करना है, तो हम जस्ट पुटिंग दिस इज इक्वल्स टू I. I'm just taking let this is equal. It means we have to calculate this value of I. Okay. What we will do, we use this property of the integration simply. So this is 0 to a fx dx is just equal to 0 to a of f of a minus x of dx. So we will use this property here. So you can easily, this is from 0 to pi by 2. Okay. So this is your first expression, first equation, and this is I will remain the I again if you are applying this property of the definite integral. So in this place you can just write root sine of pi by 2 because a is pi by 2 minus x here divided by this is root of sine pi by 2 minus x and plus this is root of cos pi by 2 minus of x of dx. So from here you can have this implies what? This implies I is just equal to this integration 0 to pi by 2 sine 90 minus theta cos theta. This becomes simply cos x. Okay, divided by simply this is sine किस में convert हो जाएगा cos में. This is cos x and this cos will be sin x. Okay, and this is dx, and this is equation number 2. Okay, you can see the different expressions in 1 and 2, but they have the same values. So we are adding this, adding 1 and 2. So we are, when you are adding, you will get 2 times I, and this integral from 0 to pi by 2 root of sin x, and this is the root of sin x plus root of cos x dx, and plus this integration 0 to pi by 2, and this is root of cos x divided by this is root of cos x and plus root of sin x and dx. So this is our in this LHS, this is I, the 2 times I, and then the RHS we added both the expression, and we can see in the denominator of the both the expression is same. Okay, so you can add because the limits is same, so you can add these two intervals from 0 to pi by 2 because limit is same. So you can write like this is sine of x plus this is root of cos of x because numerator will be added because denominator is same, root of sine x plus this is root of cos x. Okay, this becomes looks like this. So now you can have same numerator and same denominator, you can cancel it out, and it will be 0 to pi by 2, and between 0 to pi by 2 this is never vanishes. It means both the, it means if this somewhere this is x upon x you are cancelling it out, it means it should be non-zero. So here in between 0 to pi by 2 this in the sum of this is non-zero, so it will be 1 of dx, and this will be x, and where I am integrating 0 to pi by 2, so this is pi by 2 minus 0. It will be equal to pi by 2. So what will be? Okay, so we will get the 2 times of I is just equal to pi by 2. So because we want I only, integration value of the finite integral. So this I is just equal to pi by 2. This implies this is I is just equal to pi by 4. So this implies uh, the integration from 0 to pi by 2 of root of sine x, root of sine x plus root of cos x dx is just equal to pi by 4. So this is your answer. Is it clear? So we can able to find the definite integral. Uh, if we are going to find this indefinite integral, we are not able to find it. It's very difficult. But in the finite integral we can able to find. Okay. So I hope so. You understood the rule regulations for the finite integrals and properties, how we will use the properties, and now you just do your exercises and you can able to do. Okay. So thank you. We will meet in the next lecture, and thank you for watching and keep learning from here. Thank you so much.